Hello everyone. Welcome back to the course Sustainability for Future Generations, Concepts, Technologies and Global Practices. Module number 4, Life Cycle Assessment for Sustainable Decision Making, Part 2. As earlier we discussed clearly about what are the different types of LCA analysis we can adopt for the different industries. In this session, we will know how this LCA will be useful for different industries and how this decision making can be adapted for development of sustainability aspects. So, myself, Dr. P. Swaminagaratnagiri, Associate Professor, Department of Civil Engineering, SR University, Varangal. So, we'll go for the LCA part, how it will be integrated to the case studies. So, as I earlier stated clearly, case studies are very important to understand the life cycle assessment in a proper way. So once you know the proper LCA analysis for different industries which is considered, they will be knowing what is the impact or hotspots there at the different stages. We already know we have the four processes. One is the raw material extraction, one is the manufacturing, next one is the product development, after the distribution, that is transportation, then end of the life of the product. So in this session, we will be learning about how this LCA will be used to identify the hotspots in the different types of case studies as well as global as well as India. So in global, we have different scenarios. We will be learning about how the LCA will be useful in different global prospects. So definitely this session will be given a clear-cut idea about how LCA is useful for different industries in the decision making. We'll go for the case studies which are discussed in the session. First, we discussed about the automotive industries which are there. So you see here, LCA is compared with internal combustion vehicles like electrical vehicle. That is one of the best case studies. Now we can consider how we are changing from diesel to petrol, petrol to the CNG, CNG to the electric vehicles, then electric to the hydrogen feature. So there will be possibilities, a lot of possibilities are there. So changing of fuels, it will be hybrid model vehicles has came into the picture because we should not completely depend upon one sort of fuels. That's why hybrid efficient fuels are very needed. So that's the reason why the case study is automotive industry where the changes have come from combustion vehicles to the electrical vehicles. So it will identify because of LCA only this industry was converted this petroleum fuel based engines to the electrical vehicles battery based emission. So let's see how the impacts will be go on in the electrical vehicle and how what are the emissions were there in the once we earlierly given carbon footprint, around 9 to 10% of carbon emissions are coming from the transportation. So to reduce this one, this will be one of the better case study of automotive industry, which I identifies the battery production, high impacts, but EVs reduce the emissions during the usage, not in the manufacturing of batteries. So that is one of the best way. So it will support the design improvements and cleanery supply chains will be adopted by this is one of the best case studies we can discuss about is how we can convert into the combustion vehicles to the electrical vehicle. Next is about a best is 10 to 20% of CO2 emissions coming from the construction materials. So which when it evaluates into concrete first and steel as well as the timber alternatives we can suggest for different types of materials helps us it will this case studies help us to lower the carbon based materials to lower its carbon emissions such as where we integrate into LC3 geopolymer concrete and recycle aggregate. There are several types of concretes which will be useful to us to which are lowering of the carbon emissions. So which is called as the green building certification courses, and it will be help us to get a Griha rating, lead. All this comes under this LCA rating only. So next is the packing industry. As earlier stated, lot of plastic waste or glass or paper comes from the packing industries or different industries which are used for different goods are packed and they are sent to the clients or consumers. So in this one we have the plastic, glass, paper waste, biodegradable packings, all this has comes into the picture. So let us learn how relevant the trade-off between the recyclability, transportation energy, and disposal impacts are impacting about these trades. So these are one of the best way considering how this packing industry is considered. So let me how this packing industry should be learned in a proper way. So let's all together we'll learn about this how this packing industry will be help us to reduce the CO2 emissions in a proper way. So we can relieve the straits between the recyclability, transport energy, and disposal impacts on the packing industries. So next one is about the electronic industry base. So what is the electronic industry? E-waste. Most of the cases, printed circuit boards, as well as the environmental impacts like usage of smart boards, smart boards like PCBs, printed circuit boards in smartphones, laptops, and batteries. So which will highlight the where at which process it is highlighting the hotspots in mining and manufacturing, and e-waste management is very important. So nowadays highly threat is about the e-waste management is highly threatful one. So someone can take the research on the e-waste management in a proper way, and you get the solution for the e-waste management by conducting a proper LC analysis on this. So these are some of the important industries which is consuming a lot of CO2 emissions and environmental impact, as well as the reduction in the cost analysis. So coming to the consumer products, we will discuss about the what sort of consumer products we can achieve. So LCA guides us eco labeling. One is the best way, and sustainable product design will be achieved at the end of the life cycle analysis, and helps the companies to reduce the water energy demand, as well as the metal consumption. So these are the some of the case studies we'll be discussing in this session. I hope you will be understanding what sort of things we'll be understanding by LC analysis. So this definitely will be a good session for all of us to understand how this LCA will be helpful to the different aspects of industry. So let's go with this case study. First, number one, in the global point of view, that is the Tesla in versus global EV assessment. So this case study is clearly identify that how internal combustion vehicles are come over electrical vehicle. So you see here, what are the key findings we can compare about the impacts on electrical vehicle versus the gasoline vehicles over their entire life cycle. You see here, one of the extraction period is there metal extraction for the vehicles which is coming, and then manufacturing assembly of the any usage of fuel or any electricity. Then you have to maintain at the end of the life of this product. So then higher impact is there for battery materials like lithium ion batteries, lithium-ion batteries, as well as higher impact of battery packing manufacturing is important. Battery manufacturing infra impact, and much lower emissions is there in electricity usage. So then we have the lower impact, fewer moving parts, less maintenance is there in the batteries. Recyclable is very high, so battery recycling improves the sustainability. This is the one of the best way of moving towards the conversion to the gasoline vehicles to the EV vehicles. So you see gasoline vehicles, what is the impact here is carefully. I will give the into marks for the gasoline vehicles, little lower the conversion of materials, and lower impact in the engines as well as the growth, and higher emissions are there in the fuel consumption because of high impact of emissions will be go there. And then we have the higher impact of more frequent maintenance is required for this type of vehicles, where recyclable is nowhere it is there, limited recyclable is there here. So this how the life cycle assessment will be improved, which sort of fuel is needed to us to have this betterment of this vehicle maintenance as well end of the life. You see here, EV vehicle is having a life cycle and CO2 emissions lesser than when you compare the gasoline, that is combustion vehicles. So EV vehicles are very important day to day life. It will reduce the carbon emissions. It will save the environment impact load. So greenhouse gas emissions are will be lesser. So this will help us to that EV vehicle is generating over 50 to 120 CO2 equivalent per kilometer over the lifetime, whereas it is gasoline vehicle is generating 150 to 50. So this is the range how much difference it is there. So we can lower up to the 30 to 70% of CO2 emissions through electrical vehicle. That is why shifting of vehicles from gasoline vehicle, that is combustion vehicle, to the EV is helpful to us. It's not simple, it is not a one day process came it's simple to the society. It is a long term assessment was done properly, and they clearly identify that how these EV vehicles will come as to the reduction of the CO2 emissions to the atmosphere. That is the main impact we have to consider, how this LCA is helping to this industry making more amount of sustainable end product. So you see here key insights we have: EVs have better manufacturing initial environmental impact will be increases, but EVs have reduced the life cycle CO2 emissions by 30 to 70%. So it is recyclable signal improves the sustainability performance. Then use of phase emissions are much lower than the conventional vehicles. So what we can take away from this analysis of case study of electrical vehicles versus internal combustion vehicles. So the main consideration is was sustainable climate benefits was empowered for cleaner electricity, electricity. In future, there may be a chance to generate the solar power energy based cars also. There is no doubt at all. Definitely it will becomes. So like to understand and how we are getting into the key insights and takeaways from this electrical vehicle case study. So this is one of the best case study where we can understand the proper LC analysis can lead to the development of country as well as the globally. So now we see there is a lot of shift from commercial vehicle to the EV vehicles. So most of the people are converting from utilizing of electrical vehicles. So this is one of the best case study in by based on this LCA is the one of the background for converting of EV vehicles. So next one we have the case study as packing materials. As earlier I told clearly for packing of materials CO2 emissions are around considering about 10 to 12% in the global way. So why this was happening? Because we should think about the packing material is one of the huge impact in the society. So you should understand. We can simply speaking that packing materials is useless and we can throw it out, but not. So when you are starting with the case study of plastic versus glass versus aluminum versus paper packaging material, once we see the impact from each and every one. So when you see the PET bottle test, one is the impact categories like climate change, energy consumption, water consumption, transport impact, recyclability, renewability. These are the parameters I have considered to have to compare the plastic bottle versus glass bottle versus aluminum and paper cartoon. So people to try to understand the scenario. What is going to happen when you use the PET bottles? So you see here climate change is low to moderate, and when you go for glass bottle, it is very high. Emissions are very high. When you go for aluminum beverage can, moderate to high. So when you go for paper or carton beverage carton, it's a moderate. So you have to prefer for the paper or carton beer in sort of using of um, climate change emissions. So next was energy consumption is very low for the PET bottles, that is plastic bottles, but glass bottle is very high, and aluminum beverage can is very high, whereas in the paper carton is moderate. So water consumption is very low for the PET bottles, and glass is high, and whereas aluminum beverage is low. So whereas in carton it is also a high value. So but in this case only water consumption is low in your aluminum based. So that is one only one point we can consider it, but remaining is very high. But okay. Next we go for the transport impact weight based. Plastic bottles are very low light weighted as we know that, and glass is very heavy, but low to moderate is aluminum, and it is moderate for the so be paper or cartoon. So then we comes consider the recyclability effect. So moderate is PET bottles, whereas the excellent recyclable material is the glass, and excellent highly recyclable is the aluminum, and moderate recyclable is the paper or cartoon. Whereas renewability or energy sources, when you consider it is, it's low fossil fuel based one. How much of embodied energy is involved? That is renewable resource sources is low. Whereas here aluminum, it is abundant raw materials can be energy intensive. So low minimum required is highly renewable paper is paper. So from all this point of view, overall sustainability look. So PET bottles are good when recycled only. So but energy intensive is the using of glass as packing material. Good when it is recycled is the aluminum can. So good when source is sustainable. So these are the some of the case studies we can understand how this amount of the packing materials will help us to decrease the carbon emissions. You see here life cycle stages are there as I clearly mentioned. First stage is raw material extraction, manufacturing, distribution, usage phase, end of the life. So when you think about the reuse, recycle of triple R formula for better tomorrow, then only it will be happy. This is a sustainability product. So this is understand that highly recyclable metal is the glass, but is a highly energy incentive. Copper is renewable, but may require high water consumption because of it absorbs more. No single metal always the best. LCA will release the trade-offs and supports the informed metal selection based on the combination wherever is possibility we can go for that. So these are the some of the inputs which is given for the case study on packing materials, whereas plastic versus glass versus aluminum versus paper packaging industries. So we can evaluate clearly which type of mineral will have high amount of environmental impact and also give the low amount of energy emissions. So you try to understand this the concept in a proper way, then you implement this and you improve this LC analysis in getting the inventory data analysis. Then you go for the whether the which type of metal will go for reduce and reuse and recycle. That is the best way to conclude how the LCAs will helpful for this packaging materials. Next, the global case study is about the construction material. As earlier I told clearly, construction is the one of the huge impact. Industrialization or construction industry, the impact is 15% of CO2 emissions are emerging to the atmosphere. So we should understand which sort of material is. We all know that CO2 is emissions from the cement manufacturing. So what sort of things we are doing to reduce that impact in the CO2 emissions? So there's a possibilities are low. Nowadays we are thinking as India as clearly mentioned that every country is seeking to reduce the carbon emissions by the construction materials. You see this case study conventional cement versus LC3, and LC3 means limestone, calcine, clay cement, which cut down the 50% of cement, and geopolymer concrete. So objective is to compare the carbon footprint and lower the carbon fighter systems. So what are the key findings here? So we can find out the Equally Polytechnic Federal University and the partners reported that LC, that is Skrinavar, is one of the best researcher which is introduced to Indian also. Skrinavar was the scientist which is from Switzerland. She came from India and he had developed the LC3 cement from IIT Madras and IIT Delhi. So the scientists have developed a lot of things, and they have developed now code for the LC3. It's a great initiation. I will discuss in this case study in the next level of India how this LC3 was incorporated, and there is a codal provisions to nowadays to utilize this LC3 cement as a replacement to the conventional cement. So why? Because 1 ton of CO2 generated from cement manufacturing by manufacturing of 1 ton of cement. That is the highly mostly CO2 emission material. So we have to cut down. Already several materials has came into the picture, that fly ash based, GGBS slag based. So you should understand the how we can reduction of that. So step by step process involved in the cement manufacturing from a material extraction to the end product. See, this is one of the best case study for civil engineers who want to do the LCA analysis on different product. You can do it by using of open LCA. That will be help you to know what could be the best way of the green technology of concrete production. So you can extract the raw materials and how much of energy is input is there, then how much of clean temperature should be raised by the fossil fuels, biomass, all these things. So try to understand the concept in a better way. From which stage, which in manufacturing unit, from stage to stage, you should analyze and clearly know the inventory data analysis. Then only we can identify which type of zone is hotspot. So, for example, for cement manufacturing hotspot is the clean temperature. So we want to raise the temperature up to 1200 to 1400 degrees Celsius. There we require a lot of fossil fuels. So biomass. So there we have to understand that how we can reduce that clean temperature. For that clean temperature reduction only, this low calcine was came into the picture, which can reduce curtain of 600 degrees Celsius. That was the low calcine clay cement based cement. So this how the reduction is about 40%. Not only India, it's about the global. It came from global to India. So geopolymer can reduce. One of the alternative to the cement was the using of waste products which are coming from the NTPC, that is National Thermal Power Plant Corporation, that is fly ash, as well as from the steel industry there will be waste byproduct that is called as GGBS, ground gas blast furnace slag. By to alter this, to trigger these two materials, we require polymerization process. So polymerases are acquired in the alkaline activated solutions. So you may be using nowadays all people are using alkaline solutions. There is a research should be concentrated on that one. Using of alkaline instead of going for sodium silicate and sodium hydroxide, someone should concentrate on alternative alkaline products to develop the geopolymer concrete. That is one of the research innovative. So try to understand this and how to develop this geopolymer up to the 40 to 80 depends upon the precursor materials and activators. I tell activators are alkalis, and precursors are the fly ash and GGBs and metacholine, rhesus gas, what not. Whatever the precursors will react with alkaline activators, they can use it. So performance and durability remain as I earlier stated. Municipal solid waste and the biomedical waste in the previous sessions, you can use it that one, and you can do innovation in the product development. So alternative point is one of the effective pathways for decarbonizing the construction industry. Recycle aggregates as well as utilizing of recycled materials, recycled steel, all these things helping us to get more amount of sustainable products. But still there are challenges like utilizing high emissions for the manufacturing, high energy consumption, and natural resource depletion is one of the high impact. So then we have the larger water consumption is required for this one. So these are all the challenges to face in the construction industry. What are the solution benefits we can do? We can cut down the CO2 emissions up to 40% by utilizing of alternative binders, lower the energy by utilizing of alternative fossil fuels, and water requirement can be recycled within in the circular economy point of view, waste recycling process. and a lot of waste which is depletion. Then we have the durable and high performance will be comes to the concrete. So it will long living, which is it extend the life of the concrete to the 20 years and 30 years. That's how the civil engineering means you have to incorporate these sustainability aspects and you have to work together and integrate the sustainable aspects. So then is the impact is like climate change mitigation is one of the best way. And we have the conventional natural resources or conservation of the natural resources is very important. And we have the sustainability and resilient infrastructure will be getting the picture and benefit for the future generation. That is the one of the best way to conserve the resources for the future generation people is one of the important analysis we have to do from the LCA. This is how the global impact will go through LCA analysis from construction materials like especially for the geopolymer, conventional cement and LC3. So this will be the best case study if you go take it up and do the LC analysis for these three products. Then coming to the Indian context, what are the sort of case studies will be considered in Indian context? So you can see the Indian railway system, how they change their from fire plants to the different sectors. You see here, assess the environmental benefits for the railway transport compared with the road transport. See, clearly they have evolve the electric traction. Each and every track they are doing electrification. Then after they are powering up the solar powers whenever the platforms are there. Each and every platform is equipped with the solar panels. That's how they are thinking about to generate the renewable energy, which can cut down the utilization of normal fossil fuel burning based electricity rather than be depend upon clean energy. We can depend upon clean energy by installing a lot amount of solar panels, windmills, wherever the possibilities are around the track. So that will be help us to boost up the electrification tracks as well as to boost up the Indian railway in a proper way. That was the case study, and they have implemented a lot of things into the how the Indian railways are making the tracks are electric traction that will help to cut down the emissions of CO2 which is manufactured through the fossil fuels. So solar power base or windmills base, wherever the possible nearby the tracks, you can install this type of windmills or solar panels. You can cut down these emissions to that. So you see here, road transport is generating amount of 60 to 90 grams per ton per kilometer, whereas your electric rail transport is generating 10 to 20 grams per ton kilometer. That was the advantage of using of this electric transaction based trains rather than going for road transport. Road transport will burn more amount of CO2 gas, CO2 emissions. It will have the more impact in the CO2 emissions, which is around 60 to 90. So it is more value. So you have to cut down that utilization of this rail transport. That it can be cut down by up to the 80% of lower emissions will be by using of electric transaction. That is the Indian Railways already they have started and they have implemented. This was one of the best case study in India. Implementing of electric traction tracks. That was the best way of Indian, which is Atmanirbhar Bharat, and as well as for the Modi government is helping us to boost more amount of renewable energy. That is the one of the best case study. We can see here how they are lowering the environmental impact across the life cycle. When you think about the electricity from cleaner resources, efficient electric trains, lower the like metro trains, lower energy consumption, reduction of greenhouse gas emissions, gas better for our planet is one of the best way. Economy, environment, and socio. So these are the three pillars of the sustainability of this course. So we have to think about these three pillars. Triple bottom line: planet, profit, people. So that was the main agenda of these sessions is to understand how we can safeguard this. Then key benefits from this Indian railway schemes which is encountered was their reduction of the greenhouse gas emissions per kilometer and electrification of renewable integrating of further reduction of carbon footprint. The LCA makes supports the whatever the analysis they have done and they have incorporated. LCA is the background for all the things. So every industry will seek for LCA analysis only. They clearly analyzed how this Indian railway powering of sustainability electrification of the tracks. So infrastructure upgradations and cleaner track systems adopted in LCA support only. So rail tram is one of India's most sustainable large scale mobility solutions nowadays. That is the best way we can say this is one of the best case study. We try to understand this how this becoming as electric transaction, renewable energy, sustainable mobility is one way. So how these Indian railways are benefiting in lowering of CO2 emissions, low energy consumption, and reduction of noise pollution, as well as supports India's green mobility and net zero goals. Net zero energy is the ultimate goal by 2047 by the Indian government. So all of you understand that concept and understand how this LCA is evolving in each and every industry This was the best case study. If people try to understand this case study and adapt of considering the different rail motivations and how much amount of LCA is adapted for this train moving different tracks and electricity consumption and which type of vehicle movement is better for the future of India. Thank you. Next, we'll go for the next case study is about the low carbon concrete and circular construction. I told about circular economy and I want to point about the circular construction. Circular construction is one of the best noting point. We have to understand that how that material is coming to the next level of recyclable and again you have to use in the construction. That was the one of the best way. This is sustainable building material is one of the best concept to try to understand how we can effectively recycle these materials. See here, I talked about in a global LC3 and India also has adopted recycled materials in India construction. So let's focus on what is the recycled materials. One is the fly ash waste byproduct coming from the NDPC. Next is the calcined clay, lowering of the clinker temperature and using of waste clay as well as the low calcined clay materials and recycled aggregates which are the already depleted materials. So which are the key findings is what? LC3 reduced the cement emissions of CO2 while manufacturing of cement by 30 to 40%. Try to understand. Whenever we think about the CO2 emissions are very high in the cement manufacturing. So by using of LC3, it will help us to reduce to 30 to 40%. Then you are utilizing of waste recycle aggregate into the construction again by not we are cut downing the natural resources into 50% and LC identifies the optimal combination of balancing strength and durability and sustainability of the materials. So that was the main agenda of how LCA evolves and identify to optimize the how much amount of cement we can reduce as well as we can reduce the we can improve the strength, durability, and make more sustainable concrete. So, what is the main key impacts of the sustainable building materials here? You see here, whichever the product we have manufactured, it's a recyclable product as well as the zero carbon emissions are lower. Maybe fly ash bricks, maybe alkylate concrete bricks, and green steel. Green steel is recyclable steel, geopolymer concrete, LC3 based cement. All these things make a huge impact. So it will improve, lower the carbon emissions, impact the climate change, resource efficiency, circular concrete, that is circular construction, and durable and strong performance concrete for long living. So these are some of the approaches where we have to go for the circular construction rather than for the linear construction. Sorry, it's a linear construction. So that was the main important criteria you have to consider as a low carbon concrete and the circular construction. That means we are again recycling and reuse, and that is triple R. That was the main intention. Wherever you go, three pillars, triple bottom line, and triple R. That is reduce, reuse, and recycle. Don't forget, unless you, whenever you talk about the sustainability in every part, you have to think about the three pillars, triple bottom line, triple R. So these are the most important words we have to understand how the sustainability concepts are revolves in each and every industry. So this is about the case study in India, which is our approach was clear how we are making strong sustainable building materials for better tomorrow and concept of future generation was clear. So we have to give future generation something which we should be not completed by this. We have to give without compromising the present needs, and future generation should be sustained for this climatical action as well as the material conservation. Whatever the things you are enjoying today, the same thing should be given for the future kids. Try to understand and integrate for these policies. So India is having a strong potential scale for the low carbon concrete technology using locally available materials one of the best way. Whatever the locally available Indian government, we have to seek to development of that locally available material to reduce the transportation and as well as the high environment impact things. So that was about the case study about the Indian scenario of the how we can reduce the low carbon emissions and circular constructions. So when you take about the steel, as steel is the highly consumable material, we know that steel is a recyclable material. So already assessing of environmental impact for the steel production, where they are cutting, where is the possibilities there? They are cutting down and process was optimated by the energy consumption by 17.8 kilojoules of ton per steel was generated. So this was the best energy consumption period where 1.45 tons per steel was generated every by 18% was cut down by the final year. So this is the graph here shows the how we are cut down in the steel by manufacturing by using of LC analysis only, and recycling is almost 87%. It will be it is improved for 9% by year by year. So this was the circular economy concept was steel industry. How we can recycle effectively, reuse, recycle and remanufacture. This how the raw material extraction again we are taking about and we are doing. So the key insights of this one is very energy, high energy usage and CO2 emissions are less and increased scrap recycling significantly reduce the emissions and energy demand and lowering the natural resource. Waste heat recovery is one way and renewable energy improvement. So this based on LCA analysis only, we are optimizing that toward the sustainable future of steeling in India. That is a reasonable way we have to understand reason responsibly. We have to understand that, and we have to steel manufacturing helps to produce of low carbon steel. That is also the best way for construction as well as the automotive applications. Not only construction, automobile industry is also utilizing of large amount of steel. Try to understand and integrate of which is stronger for betterment of green tomorrow. That was the case study of the Tata Steel Limited, which will progressing day by day and decreasing the carbon emissions. Energy demand also was reduced, as well as recycle rate was increased. That was how the circular economy was integrated with the LCA. That was the outcome which is coming from the Tata Steel case study. Then how the product will develop can be used in LCA. So you can see here how product developers, who is the product developers, industry people. This LC will help us to make data-driven designs, decisions can be made and identify the hotspot. That is the best way and reduce the cost of the manufacturing and get the proper support from the circular economy and meet the standards and the build trust among the consumers. So how LC help to at every step? When you take the design driven decisions, concept and device should be evaluated and you have to make the alternative and lower the impacts on the options. Then material selection is important, then processing of manufacturing is optimizing the process to reduce the energy usage and waste, as well as the supply chain, logistics, and environmental impact. End of the life strategy plan. Disassembly, you can understand the recycling and disposal methods and continuous improvement in the process, track the performance, driving to the large amount of sustainability gains will be encountered. These are the one of the how product developers can use LCA into the best point of in the sustainability development. So you see here community sustainability will come from SCA and iterate and improve it and collaborate across the teams. Then use reliable LCA tools like open source so LCA or SIMA Pro tool, which will the basic of version which is now the high inventory database. Then use of LCA early, the integrate of LCA will be help us to integrate more early design. That was the best to get this best community sustainability product. LCA empowers the product development to design smarter and have the innovative responsibly and build better future for the better future generation kids. That's how the LC will help us for the product developers. Why it matters for global sustainability development? You see here, whenever the products our planet, LC help us to reduce the pollution, improves the quality of life, drives the economic growth and accelerate the circular economy, supports the policy and goals, and builds the better future. This all together, where first impact was the CO2 emissions, next was the natural resource depletion, next thinking about the sustainability product, and next about the LC data-driven decisions will be making. All together contributes to SDG, Sustainable Development Goal 17. In that 17, LCA is contributing to 3, 6, 7, 9, 11, 12, 13, 14, 15, and 17. See, that was the major contribution from the LC analysis is not just him, but is essential for achieving our sustainable, equal, and resilient world for all. So that was the major impact. Some of the numbers to that emphasize how much it at stake by conducting of LCA analysis. So global warming potential was decreased 1.1 degree. The world is already having warmed. So then 50% of emission must fall. That is the agenda. So that was keep the 1.5 degree within the reach and 19 trillion economic opportunity was there and greater than 3 years resource consumption was reduced to the and 931 million tons of waste generated was municipal regenerated and you have to think about that and technical the environmental cost whatever that gigatons of carbon emissions should be reduced and 2.2 billion people live in countries 10 million hectares of years we have to consider and 1 million species are there at risk of extinction of the coming decades. So global electricity was 73% in 2023 were renewable and 70% of emission reduction by 2050 is the agenda of LCA by conducting a proper analysis. So this was the how the future of not automatic but is a choice and the numbers makes it clear what sort of action will be considered for this. So on the earth 7.8 billion earths today our choice to impact every one of them. So the triple bottom line is clear. The time is act now. for our planet, our people, and our shared with triple bottom line is one of the thing we have to consider and understand the impact of LCA. So how this one balancing the data availability challenges is there. We have to balance the data in a proper way. For LCA, limitations are there and challenges are there everywhere. So you see here data availability issues are there. So high quality of consistent data is required. Be patient and collaborate with industry people and try to get the more amount of data. And then comparable challenges are there. We have to understand and that and we have to utilize it. Dynamic changes are there. That was the challenges and limitations are there. We have to fix the boundary of the LCA analysis and we have to know cost and effort affordable for LCA test too. Expertise requirement is also important. Don't simply do the lower cost and give the product. Expertise important was requires specialized skills to experience to perform interpret accuracy of the data in a proper way. So this balance will lead to the better editions for the LCA. So try to understand that simply don't go to the software and do the analysis. Proper knowing the procedure of the manufacturing process, which are the steps involved, and get the data in a proper way. Don't lift over any simple step also in the manufacturing product of end product. Cradle to grave is one of the best method to do it, or else you can do for the cradle to gate also it's okay. But cradle to grave is one of the best way to identify the what sort of hotspots are there, environmental impacts are there, and what's the optimizing process are there. So the balance leads to the better decisions in LCA. So try to understand this and get the limitation challenges where we can use the LCA in a proper effectively for sustainable development feature and decision making. That is the end of this part 2. Decision making is very crucial by sustainable goal. So this is how the life cycle analysis will help us. And I wish you have enjoyed this part 2 of life cycle assessment. This was the holistic approach for the better planet, where we start with the circular construction, circular economy, and cradle to gate or cradle to grave. Whatever it may, one planet, one choice, and one feature. Let's make more sustainable and more eco-friendly of ecosystem should be also sustainable. Thank you. Thank you for the viewers and subscribers. Kindly like it. These are the some of the references. View it and we have integrated and you can get the contact with me. You can go with the email and you can message me or you can link with the LinkedIn profile. Thank you for viewing this. Jai Hind.